Hello. In the middle of our linear equations unit, we have to review solving linear equations, and because we're pre-calc, we got to make sure they're kind of nasty. So nothing makes a linear equation nastier quicker than if you throw some fractions into it. So if you're anything like me, you don't really appreciate doing algebraic work with fractions unless you have to. So if there's a way to get rid of the fractions, let's look at that. So the first few questions are going to be total review for you guys from even Algebra 1. Remember, solving linear equations, you want to use the distributive property, collect all your like terms, move the variables to one side, constants to the opposite, and then solve. So we're going to want our answers in improper reduced fractions if necessary. So my first step is to distribute this 2. So 2v plus 6 equals 10 minus 2v. A lot of kids think those 2v's will cancel, but they're not going to. We're going to add this 2v, which means we also add it over here. Cancel out that term. At the same time, I'm going to go ahead and subtract this 6, moving my constants to the right. So 4v equals 4. And then finally, dividing by 4 on both sides, v equals 1. So probably didn't have to do that equation for you, but that's a nice warm-up for us. This next question, this is more our style here in pre-calc. So it's a lot of fractions, and I don't really like working with fractions. I surely don't want to change them to decimals because often, and this is the case in some of this problem, the fractions, if you convert them to decimals, are not going to be exact because you're going to truncate them because they're irrational decimals or repeating, perhaps. So, well, they're not irrational, duh. They're repeating. So anyways, here, if I look at my denominators, I have a 12, a 2, a 6, and a 2. So if I can find what's called the least common multiple for all of those values, and the 2 repeats, you don't have to think about it twice. So 2, 6, and 12. And it really doesn't have to be the least common multiple, it just has to be a common multiple, something that is big enough to divide into all those numbers. And it can be bigger than the smallest one, but that's going to give you more work. And since we try to be able to do this without a calculator, I want to go with the smallest common multiple. So for us, that would be a 12. So what happens here is if you were to multiply every single term in this equation by a 12, you're not affecting the balance of the equation, but you're going to rewrite the equation in a different form, but it's still going to be equivalent. So the reason a 12 is going to work here is because when you multiply like this first fraction, 12 times negative 1 over 2, or 12, you can do the multiplication or the division first. It's up to you. So you want to do what's easier for you. So for me, I would think dividing would be easier first, and then I get a smaller number, and then I can multiply, and that's something I can do pretty easily in my head. So for instance here, 12 divided by 12 is 1. 1 times negative 1 would be negative 1. 12 divided by 2 is 6. 6 times 3 is 18n. 12 divided by 6 is 2. 2 times 7 is 14. And then 12 divided by 2 is 6. 6 times 3 is 18. So you do have to do a couple of operations at the same time in your head, but all right. Now the same rules as equation solving applies. Get everything to one side. I do notice I have some like terms right here I'm going to collect together. That would be 32. So we have 18n plus 32 on one side of the equation equals negative 1. And I want to do this in as few steps as possible. So I'm thinking keep the n's where they're at, but let's subtract that 32. And I can nearly guarantee that these answers will come out weird and not reduced to whole numbers or integers. So don't panic when you divide both sides by 18. And this is where, you got to start thinking like a lazy math person. You don't have to grab your calculator. It actually might be easier if you do this without the calculator. Both of these are divisible by 3, right? So negative 11 over 6 is the reduced answer. Math, enter on your TI-84 calculators will give you the same answer. What I don't want to see is the decimal equivalent to that, because in any format that you would round off the number and you would essentially truncate it, thus not actually being the right answer. So, sorry. We're going to skip the next one. I'm going to let you do that one for homework probably. Ooh, 4. 4 is fun. So we have fractions, which I'm not super excited about. We also have a distribution component to this question. So there's a couple ways we could approach this question. In my opinion, it's easier to take care of the distribution and get rid of that first set of parentheses, and then you can use your LCM method if you want to get rid of the fraction. We will. So if I distribute the 4 here, oh gosh, let's see. Remember, we can divide first if that's easier. So 4 over 6 is really 2/3 times 23. Now nothing else divides or reduces there. So I do get 46 over 3. Again, you could use your calculator if you're really in a pickle. But remember, there's a whole component to the SAT test where you can't use a calculator. So you want to be able to work with fractions pretty easily. And then 4 times 27 is 28. And then, let's see, 284 over 3. So there are still fractions here. The good news is really not that bad. At least in an effort for us to get rid of them, I noticed the denominators are both 3s, which means if I just multiply everything by a 3, it's going to be great. So when I multiply the first fraction by a 3, the 3 divided by 3 is going to cancel to a 1, and 1 times 46v is 46v. Oh, 84. 3 times 28 is 84. And then 3 divided by 3 is a 1 times 284 is 284. So now I have a nice equation. It's equivalent to the original. I've just manipulated it in a way where I no longer have to worry about fractions. Probably will now, though. Okay, spoiler alert. I kind of already did this problem. So I'm going to sneak a peek at my key so I don't have to add anymore. Let's see here. 368 equals 46v. And this fraction will reduce. I can tell because they're both even. How far will it reduce? I don't know. If you're in a jam, just grab the calculator. You don't have to hand reduce. This actually reduces beautifully. It comes out to 8. That is not always going to happen. So I'm not always going to have integer answers. And then here, good times, guys. We're going to distribute, I would say get rid of the 11/6 first by distributing it through. This is not the only way to handle that question. I just think it gets really complicated if you try to do the LCM component to this process first. There's already parentheses. You have to be careful about that you're not doubly distributing whatever your LCM is. That's my word of advice. But here, 11/6 times 7/2, again, you want to be able to think about this on your without the calculator. And that's a super bummer, right? Because nothing reduces. So I don't know if that's good news or bad news, but it's negative 77v over 12. Ugh. And then negative 11/6 times the 1/4. Okay, same thing. Nothing cross cancels, nothing reduces. Okay. Ugh. What I do notice, though, is the negative times the subtraction is going to be a positive sign now. And then 11 over 24. I still have a minus 4v right here. And I still have an equals negative 824 over 9. All right. So, good news, I guess, is we're ready to get rid of the fractions by thinking about an LCM for 12 and 24 and 9. So, this is where you have to kind of decide where you want to spend your energy. I mean, you could spend it finding the actual least common multiple for 12 and 24 and 9. Or you could just find any common multiple of 12 and 24 and 9. And sometimes the multiple that you're kind of thinking about is actually the least common multiple. But one thing I noticed is 12 and 24, that's easy for me to do in my head. The common multiple, the first one that shows up for 12 and 24 is 24. So essentially all you need to figure out is what is your common multiple for 24 and 9. So what I just wrote there is something that you can actually do on your calculator. You do have a feature on your TI-84 calculators that allows you to find least common multiples, but only between 2 values. So now that I've narrowed it down to just 2, 24 and 9. Okay, close. All right. That said important. I probably should have read it. Okay, if you hit math, and then you go over in the math menu to where it says NUM, numerical something or the other. And then number 8 down here is LCM, least common multiple. So remember our numbers were 24 and 9. So if you type 24, 9, it'll pop out the least common multiple for them, which happens to be 72. When I originally made my key, I didn't have my fancy calculator with me. I just had like a cell phone calculator with me. So what I did is I just multiplied 24 and 9 together, and I got 216 apparently, which is a common multiple of those two. It's not the smallest common multiple. So when I originally did this problem, I threw a 216 out here, but I just found out from a calculator that actually 72 would work as well. Now, because I don't want to grab my calculator anymore and I already have my work done with the 216, I'm going to go ahead and use 216 as a common multiple. Ooh. It is not the least common multiple, which we found out was 72. So my word of advice is just decide where you want to spend your energy. If you have a calculator, like who cares? Because you're going to type it. If you can't use a calculator, then that's kind of bad news. If you want to make the problem as easy as possible. In that case, I would try to use the smallest common multiple if possible. All right, when I distribute this to 216 to all the terms, like I said, I already keyed this out, so I'm just going to kind of look at my answer key and feel my numbers. I got negative 1,386 v on the first term because I did 216 times this fraction. And then my next fraction came out to 99. And then 4v also has to be multiplied by 216, so that's 864v. And then this last fraction, oh, lovely, negative 19776. Yeah, that's not great. Thank you, calculator. All right, so we're going to combine our like terms here on the left-hand side. Gives me a negative 2250v. I still have a plus 99 equals negative 19776. And now I solve. So this is a really gross problem. But, you know, we're in pre-calc and we can handle this. So negative 19875 divided by negative 2250. Man, really need to work on my handwriting, don't I? And then after a little calculator magic, math enter, bringing it back to an improper fraction, 53 over 6. Lovely. All right. So that's a nice refresher of solving linear equations, but then we're going to kind of amp it up here for pre-calc where your linear equations are going to have lots of fractions in them with various uncommon denominators. So rather than working with the common denominator component of how to add and subtract fractions, we're just going to wipe them out. Only thing that allows us to do that is that these were equations, meaning there were two sides to the balanced scale. If we were looking at an expression, such as like 2/3 x plus 7/5, you can't do anything to that because there's nothing to equate it to. So you're kind of stuck with that ugly expression. So just keep that in mind. You can only use the LCM technique for when you're solving an equation. Equal.